These are the 1.2a notes for PreCalc. We're going to be talking about intervals on a graph and average rate of change. So intervals on a graph we did last year in Algebra 2. We talked about where things were increasing and decreasing, as well as where things were positive and negative. So if you have a colored pencil or a highlighter or a marker, I would suggest you use that. I'm going to use two different colors here. I'm going to use pink and blue. So what is increasing? Increasing is when the graph is going uphill. In other words, this area right here, increasing, and also this area right here. So see if you can use your highlighter or colored pencil to kind of fill in that area so you can see the part that's going uphill. I'll switch over to the other color. What is decreasing? Decreasing is when you're going downhill. And remember, you always read your graphs left to right. So you always read them that direction, just like you read words on a page. So the downhill sections would be this area right here. So it's going downhill, as well as this big chunk right here and all the way out to the bottom. All right. So then how do I actually say that little interval, that section of the graph? So increasing, this first pink part, anytime you have that arrow that's going over to the left, you say from negative infinity all the way up until, and then you read the numbers here on the graph, all the way up until -4. So you never want to read these numbers here. Those are your y values, and we always want to write our x values. Then Delta Math asks you to put the word or in the middle if there's two sections. And then the next section goes from -2 all the way to 1. -2 all the way to 1. And we're always going to use parentheses for increasing and decreasing. Now let's look at the decreasing section. We have this first blue section, which looks like it's going from -4 to -2. And then you have this other blue section, which looks like it starts at 1 and goes on. And notice that arrow right there means it goes on forever. So it'll go from 1 all the way to infinity. Next thing we're going to talk about, example number 2, is positive versus negative. So positive means that the graph is above the x-axis. So above the x-axis would be this section right here, all of that area. And negative means below the x-axis, which would mean this little area right there with our arrow, as well as this little piece over there. All right, so let's name these intervals again. Positive is going to be this big pink section here, which would be from -7 all the way over until, and of course I covered it up, all the way over to 2. And then the negative intervals, the blue intervals, would be from -infinity, since that arrow is kind of going off to the left, all the way to -7. And we use the word or. And it goes negative again at 2 all the way till infinity. It just kind of keeps going in that direction. All right. And for these, there's always been a kind of a debate about which ones is best to use, parentheses or brackets. And the good news is Delta accepts either one. So you can use parentheses or brackets. I'm usually going to use the parentheses though, just so it's the same as the increasing and decreasing. On the back page, we have something called average rate of change. This first two pictures is just two different random graphs. They have nothing to do with the problems down below. It's just so that we can talk about the difference between average rate of change and slope. So the slope is only used for a straight line. And it's consistent all the way through. So slope is rise over run. If you look at this one right here, you can see the slope is up 1 over 3. And then if you keep going, it's up 1 over 3, up 1 over 3, up 1 over 3. It's the same the entire way. But the problem is we can't use slope for things like parabolas because they're curved. So we're going to use average rate of change for anything that's curved. And your average rate of change could change. If you're just going from here to here, it could be different than if you're going from here all the way up to here. You can tell it's a much steeper line as you go from those second two dots as opposed to when you go from the first two. So your average rate of change can change depending on which interval you're looking at. We're not going to explore too much on the graph. We're just going to look at our examples here with the equations. So how do I find the average rate of change? You're going to use the formula f of b minus f of a over b minus A. A and B are going to be the two numbers that they give you. The first one I always call A, the second one I call B. And we'll first start by just plugging in A and B into the equation right here. So f of 3 minus f of 1 over 3 minus 1. Notice I haven't done anything with that yet. Once this is set up, we're going to actually find an answer for this right here, f of 3. F of 3 means to plug in 3 for the x right here. So I'm just going to come off to the side and do f of 3, which just means plug in 3. I'm going to plug it into that equation. 2x squared, 2 times 3 squared. We're going to do our exponents first. 3 squared is 9. And then multiply out to get 18. And so when I plugged in a 3, I got an 18. I'm going to write that right there, right where this box was before. Then I'm going to bring down the minus sign in the middle. And I'm going to do the same thing for f of 1. So I'm going to come off to the side. And I'm going to plug in 1 into that same equation. Exponents first, then multiply. And I'm going to put that right there. The rest of the problem I can go ahead and leave, 3 minus 1. So it's almost like you have two miniature problems to solve as you're solving this bigger one. Once you've solved those two little problems, then you can go ahead and do the math. 18 minus 2, 16. 3 minus 1 is 2, and divide that to get a final answer of 8. So your average rate of change from 0 to 3 is 8, which just means if you had this graph and you went from 1 to 3, your slope would be 8. All right, let's take a look at the second one, example number 4. We have a new equation. We also have a new A and a B. So we'll start by plugging in the numbers in the correct place. I always put the B first there and the A. Same thing on the bottom. And then we've got two small problems to solve. One is this one right here. So we'll take it off to the side and plug in a 4 into the new equation. So 4 to the third minus 2. And this part you can do in your head. You can type it into a calculator. I'm just going to show every step to make sure that nobody misses anything, but you're more than welcome to shorten that. You got 62 for that answer. I'll put that number right there. I'm also going to bring down the minus sign in the middle. And then I'm going to work on this f of 0, which means I need to plug in 0 into the equation. When I plug in 0, it looks like that. which gets me 0 minus 2, which gets me negative 2. Now notice your answer is a negative 2, but you also have the minus sign from the problem, which means you end up with a minus negative, which we all know is going to turn to a positive. Add those together, 64. Subtract those, 4, and divide out to get 16. So far, the two problems we've done have come out to be whole numbers, but that doesn't always happen. So for example, number 5, notice they throw in this x equals 4 and x equals 25. That doesn't mean anything. That's still A, that's still B. Just different textbooks, different tests, all show things a little bit different. So we like to give you all a variety of the same question asked in just slightly different ways. See if you can do those small equations off to the side. And you can think about this as 3 times the square root of x. So as you plug in a 25, 3 times the square root of 25. Square root of 25, of course, gets you 5. See if you can work your way all the way through this question. You are going to get a fraction as an answer, and you can even reduce it at the end. I'll give you just a moment to work through that. Okay, so when I plugged in a 25, I got 15. And when I plugged in a 4, I got 6. I'll subtract and subtract. And then make sure that you reduce at the end. Both of those are divisible by 3. And you get a fraction of 3/7 for your final answer.